All right, we're going to go on to our next section. Our next section is called the binomial probability distribution. So binomial, think about bicycle being two options. So before we did just a probability distribution, and there were three things. So make sure you know those three things that you have to memorize. For a binomial distribution, which again, you have to check the requirements. This time there are 4 of them. Okay, and again, you do have to memorize them. What is the difference? Well, the other one, there's only 2 options. Well, this one is going to be, well, the other one could be many options, but this one's binomials or 2. There's a little funny acronym that goes with this. So the first one is going to be, we actually have to check if it's binomial. And what does binomial mean? It's not a 50-50 chance. And instead, is there a success versus failure? Meaning that there's no like gray area. Okay, so this is your B. Is it binomial? The next one is the trials must be independent of each other. So if I'm flipping a coin, those are independent automatically. Like you getting heads has no effect on the next one. If you're looking at people, you want to get a replacement versus without replacement. So independent, we're going to use this I. Okay, again, it's a little funny acronym that I use that's like cuss, but with binomials. The next one is going to be a fixed number of trials. Fixed number of trials, which we call N, which I'm going to use capital N, but it's N. So you're tossing a coin 5 times, or you're picking 12 people. It has to be like a fixed number of trials. And the last one is the probability of success. Has to be the same throughout. The same throughout. Meaning flipping a coin is a 50-50 chance. It doesn't matter if it's the first flip or the 5th flip. It's still 50-50 every single time. So this is going to be S. And so my funny acronym is BINS. Again, let's help you remember if it's a binomial distribution or not. And it starts with the B for binomial. I don't know. Some notations. You know some of these. You might not know some of these. So S is going to stand for success. And so what is P of S? P of S is the probability of success. Which we're actually going to only use P in this part later on. Okay, F is going to stand for failure. So what does P of F stand for? Is the probability of failure. Okay, which we're going to, again, write Q. We're going to use P and Q. My Q's, I know, are a little funny. It looks like a P with the tail. N is going to be, and I'm changing the color because it's not really probability anymore. So N is going to be the number of trials. X is going to be standing for the number of successes. Okay. And then a little formula for what you should know is Q. And Q is your probability of success subtracted from 1. Okay, and we'll go ahead and do an example of what this is. So it says when an adult is randomly selected with replacement, there is a 0.85 probability that this person knows what Twitter is. Suppose we want to find the probability of that exactly 3 of 5 randomly selected adults know what Twitter is. Okay, so some numbers that are important is 0.85. Okay, that is the probability of one person. So the probability of one person is going to be your P. Okay, we want to find the probability that exactly 3 of 5. Okay, so 5 is going to be how many people I'm looking at, so that's your N. The 3, not so much, we don't need that just yet. Well, I guess we can. 3 is going to be the number of successes, so this is going to be your X value. And another keyword is with replacement, or keywords are with replacement. And that actually helps you out with the next part. So we're going to go ahead. Does this procedure result in a binomial distribution? What this means is you have to check the requirements. Okay, so the first one is B for binomial. Okay, so really easy. You don't have to write success versus failure. You're going to tell me what is the success. So the success is, well, 85% know what Twitter is. So your success in words, we're not writing 0.85. Your success is a person knows Twitter. It doesn't mean they have one, meaning they know what Twitter is. Okay. Your failure is person doesn't know Twitter. Okay, that's first part. Okay, your second part, or your second one, is the trials must be independent of each other. So they are independent automatically because it says, because with replacement is mentioned. Okay, it means each person is independent of each other. Okay, so if I pick an adult and put them back into my log, they're automatically independent of each other. The third one is the number of trials. So what is n? Well, how many trials am I looking at? I'm looking at 5. This number is fixed. And my fourth one, I'm going to keep it the same color. My fourth one is the probability of success, which is P equals 0.85. That's my probability of success, and it remains the same. Means the same for each person. So, is this a binomial distribution? Yes. So, yes, a binomial distribution. Okay. Part B, if this procedure does result in a binomial distribution, identify the values of n, x, p, and q. So we did n already. N is how many people are we asking? We're asking 5 people. And of those, how many of them do we want to be successful? We want exactly 3 of them to be successful. What is my probability of success? That's what P stands for. Well, that gave it to me, 0.85. Well, if success is 0.85, what's my Q? Well, my Q is 1 minus 0.85, which is 15%, or 0.15. Okay? And that would be like an example of like check the procedures that label it, and then we'd actually have to find some probabilities, which we'll do in a little bit. Okay, so let's go on to the next page. Okay, when selecting a sample, as in a survey, we usually sample without replacement. Think about it. If you're asking a survey, you're not replacing them back in. You already asked this person. You're not going to go back to them. Sampling without distribution results in dependent events, which we want independent. Okay, which violates a requirement of a binomial distribution. However, we can often treat the events as if they were independent by applying the 5% guideline introduced earlier. So the 5% rule. So it says, in case we don't remember it, I wrote it down. It says when sampling without replacement, the sample size is no more than 5% of the size of the population. Treat the selections as being independent, though they are actually dependent. So for example, if I ask the entire Mount SAC students, do you walk to school or do you walk to school or you don't walk to school? Meaning that's independent and their success and failure. It's not how are you getting to school, it's do you walk to school or do you not walk to school? Okay, if I'm asking the entire Mount SAC, I can only look at no more than 5%. I can ask no more than 5% of all Mount SAC students. Okay, if I ask more than 5%, then I have to say with replacement or without. But if I just ask if I ask 4% of the population, or if I just ask you guys, my class, you guys are not 5% of the population. There's way more students, so then that would be okay. Okay, so there are 2 methods to actually solving this. We're gonna go ahead and I'm gonna do both of them, and then I'm gonna explain it, and then we're gonna do it, and then the second way is actually using technology. So the first thing you need to do is you need to know some variables. So what does N stand for? N is going to be the number of trials. X is going to be, and I'm just writing this from the first page, number of successes. P is going to be the probability of success. And I'm just writing this out so you can see it. And then Q is going to be the probability of failure. Okay, so let's go ahead and write it. And this only works with the binomial formula. Again, this is a formula you don't have to memorize because there's a shortcut to it, but let me go ahead and write it all out. So it's gonna be n factorial over parentheses n minus x factorial times x factorial. You're like, huh, I've seen this formula before. Yes, you have, but let me go ahead and keep going because that's not it. Times the p of x times the q of n minus x. And this is in a exponent part. Now, where have you seen this before? That's a combination or a permutation. Well, remember this little part right here makes it a combination because order doesn't matter. It doesn't matter if the first person knows Twitter or the third person knows Twitter, as if only exactly 3 of them know Twitter. So this is gonna be, it's not NCR though, it's NC X times, and then I'm gonna write the same formula. P times X times Q times N minus X. And this right here is your formula. And that's why if you know, if you have your calculator, you can do this part very easily. Okay, so let's say using example 1 from this section, we're gonna find the probability of exactly 3 people knowing Twitter. Okay, so I'm gonna start setting it up by writing P of 3 equals, and I'm just gonna use the formula. So 3 is my number of successes, so that's my X. How many people was I asking? I was asking 5, so it's gonna be 5C 3 times, and I'm just gonna do a parentheses, my probability of success was 0.85. And how many people were successful? 3. And what's my probability of failure? Well, again, if you look at the last page, it was 15 or 0.15. And my failure would be 5 minus 3, right? If there's 3 people successes, that means that there's 2 people of failures. It can only be one or the other. Now, I'm gonna just straight use my calculator. I'm gonna round this up. So I'm gonna do 5. Oh, let me see if I can show you guys what I'm doing. So I'm gonna go up a little more. So 5, probability, go to this one, 5C3. Then I have to hit the right arrow. I'm gonna do times parentheses, 0.85 to the 3rd power. And I'm gonna go to the right. Again, my calculator might be a little different. You might have to practice using yours. Times 0.15 to the, and I'm gonna just, I know it's squared because 5 minus 3 is 2. And how many decimal places do I round to? I'm gonna round to 3 decimal places. So I'm gonna write 0.138. And that's using my formula. Okay, what we found out, and again, you always have to write a sentence now. Oh, yay, so much fun. So I'm gonna say the probability of getting 3 heads, oh, sorry, not 3 heads, 3 people knowing Twitter out of 5 people is 0.138. Again, you can write this a lot of different ways. This is like one of the easier ways to write it. You're telling me what number you found. You're telling me what does it relate to. And so the probability of getting 3 people knowing Twitter, you can write the probability of getting exactly 3 adults who know what Twitter is out of 5 people is 1.138. As long as you kind of talk about everything, you're okay. No, only round at the end. Do not round, otherwise you'll get it wrong, and round to 3 decimal places. You guys can't emphasize that enough. 4 decimal places is also fine. 3 decimal places is the minimum. Okay, so using technology, here's the thing though, you still have to write a sentence. And you still have to label. Okay, so how do you do this on your calculator? Well, this is a binomial distribution, so we're going to be using a binomial PDF. And the way you get to this is you're gonna hit second, and we're gonna use a graphing calculator. So you go second, and then you're gonna go to vars, which is right below the on the bottom sign. And again, I'll show you guys. And then you're going to go to, you're gonna scroll all the way down to A, which is binom PDF. And P is going to be 1 value, There's a little shortcut. CDF is like when you want to go to the left or to the right, but we're not going to talk about that just yet. Okay, but if you're doing this, you have to label the value. So it's going to ask your N, it's going to ask your P, and it's going to ask your X. Okay, so let's go ahead and I'm going to show you guys on your calculator, but I'm going to have you guys write it out first. So we're the probability of finding a 3. Okay, and it's going to be, you're going to see that you're going to get the same answer, is going to be binom PDF. And yes, you do have to write it out. And then how many trials were there? Well, there was a total of 5 trials. What is the probability of 1 success? Was 0.85. And how many trials do I'm looking at? Well, this is this part right here. So we're looking at 3. Now, if you're using this method, you can, you don't have to write out this part, but you do have to write out this part, and you do have to label it. So N, P, and X. All right, so how do I get to this? Okay, well, I'm gonna hit second, which is the blue button. VARs, which is right underneath. Okay, and I'm gonna scroll all the way down to A, which is binomial PDF. I kind of already played with it. So you're gonna type in 5 for your number of trials. What is your probability? What is your X value? And I'm gonna hit paste. I'm gonna hit equals. And look, you get the same answer. And we're gonna round to 3 decimal places again. Okay. So this is good practice because the next page asks you to find them all. Okay, now if you're asked to find them all, okay, what is the easiest way to go about it? Now, I don't mind you writing P sub 0, everything, P sub 1, everything. But what's a nicer way to make this prettier is going to be go ahead and using a table. So I'm going to write X and write P of X. Okay, and I look at all these values, and that's 0, 1, 2, 3, 4, and 5. That's a lot of values. Now again, if you want to use your formula, that's fine, or if you want to use binomial PDF, that's fine. I'm going to go ahead and use binomial PDF, okay? But let's go ahead and do the formula way, actually. So let's go ahead and use the formula just in case you won't want to use the formula. You have 5C0 times 0.85 times 0, or to the 0 power, not times 0 because then it's 0, times 0.15 to the 5 minus 0. Okay, now I'm not going to write it out the formula. I'm not going to do it because I'm going to do the binomial PDF. But if you're using if you're using it this method, I'm going to write it out. 5C1 times 0.85 times to the first power times 0.15. Well, I can do this math in my head. I can just write 4. Okay. Or you could write it out like this. P sub 0 is equal to binom PDF times 5 times 0.85 times 0. Then I have to label this as N, P, and X. And then I have to do P sub 1 is equal to binom PDF times 5 times 0.85 times 1. And label that N, P, and X. You don't have to do both. Please don't do both because that's a waste of time. Okay, but I want you to write out at least 2 ways. At least 2 of them. Either one you pick. So if you're doing this method, you don't have to write all 5 out or all 6 out. You just have to write out, for me, the first and the second one. And then use your calculator. Then you can just go ahead and just do the formula without writing it out. If it helps you to write out, go for it. But this right here is good enough work. Same thing for this one. You don't have to write out every single value. You just have to do the first 2 and then go ahead and use your calculator. Okay? So I'm going to go ahead and do the first one. Again, I'm going to just do binomial PDF because it's easier for me. And I'll show you guys a little shortcut. So binomial PDF. Well, this one was for 3. So for 3, I can actually just write it in as 0.138. We already solved that. Okay, but let's go ahead and plug in 0. Ooh, this is scientific notation. So I'm going to write 7.59 times 10 to the negative 5. Okay. 1. Now here's the little trick. If you use the up arrow and hit enter, it copies the first line, and all you have to do is highlight 1 and hit enter. Okay, so I'm going to write 0.002. I'm going to highlight this. I'm going to go back down and hit 2. Yeah, I didn't hit 2, I hit a decimal. And I'm going to write 0.024. Okay, and then for 4, I got 0.392, and for 5, I got 0.444. So see if you can get those out. Now again, if you don't have a graphing calculator, there's other places online you can use, or you can go ahead and use the formula. But this right here, if you notice, it's a lot quicker. Okay, going on to another example. We're gonna do another one, and then we're pretty much almost done. So, devil of a problem. So based on a Harris poll, 60% of adults believe in the devil. Assuming that we randomly select 5 adults, answer the following parts. So here's a couple things. The first thing is 60%. We don't like percentages, we like decimals. So this is your P, and it's 0.6. Now if P is 0.6, what is Q? Well, Q is 1 minus 0.6, which is 0.4. Okay. How many adults are we looking at? We're looking at 5. So that's how many trials we're looking at. So we're saying N is equal to 5. So it says using technology to create a table for the probability distribution. Okay, so notice it didn't ask me to go ahead and check this requirements. We're just gonna go ahead and do a probability distribution. So I'm gonna write it over here because I tried doing it under in the box, and oh, see, I still messed up. I'm gonna go ahead and do it like that. Write X and then P of X. I'm gonna go ahead and write N equals 5 right here. Okay, so how many people there are? 5. So how many people can be not? And so we're always gonna start with 0, and we're always gonna end with however many people we have. So 0, 1, 2, 3, 4, and 5. Now, it doesn't matter if you use the formula or not. You have to actually write out some steps. Remember, at least 2. And it doesn't matter which 2, but I always pick the first 2. So I'm going to write P is 0 equals, and I'm going to use my calculator. So binom PDF of, and I'm looking at 5 people, and it just happened to be 5 as well. My probability of success is 0.6, and I'm looking at 0 people. Okay, so I'm going to write N, P, and X. I'm just going to write the first 2 out, and then I'm just going to use my calculator again. So probability of 1 is binom PDF, and that's 5, 0.6, and 1. So that's N, P, and X. Again, I wrote the first 2 as part of work. Now I'm just going to fill in the table. And I'm going to fill in the table. I already did it, so I'm just going to write out the answers. See if you get the same answers. So 0.010. I'm going to write to 4 for that one, just because otherwise it's 0.010, which is fine, but makes it easier. This one's 0.077. This one's 0.2304. This one is 0.346. 0.260. Actually, wait, 59. Sorry, I'm gonna do that one wrong. 0.259. I can round. Number 5 is 0.078. Again, pause it, see if you can get those answers. I just used my calculator and go ahead and did that. The probability that exactly 3 of the adults believe in the devil. So I'm going to write the probability of 3 equals, and I can just use the chart. Okay, I don't have to actually show my work for it because I did all the work for all of them. So the probability is 0.346. Now, if you're asked to find something like this, guess what now you have to do is you have to write a sentence. And how do you know to write a sentence or not is when you're actually asked to find the probability of things. Now you actually have to go back, and every time I ask you, what is the probability of this? Or what is the probability of this, like filling it in, you have to write a sentence now. Okay, so it's really simple. I'm going to say the probability that, and I'm just going to read the problem. So the probability that exactly 3 of the adults that believe in the devil is 0.346. Something really simple. The problem tells you what to write in. All right. What is the probability that the number of adults who believe in the devil is at least 2? Now remember the words at least. That's 2 or more. So the probability that at least 2 or more people, so I'm gonna write X is greater or equal to 2. Okay, so again, you kind of have to know what to, when I say at least 2, that's 2 or more. So that's really the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5. Okay, and how I get this is I'm just gonna add the 4 numbers together. Okay, so I'm gonna write 0.2304 plus 0.346 plus 0.259 plus 0.078. And then I'm not gonna actually calculate it, you guys are, because I didn't actually do it, so then you can see what you get. And then you would write your sentence. I would say the probability that the number of adults who believe in the devil, at least that at least 2 adults who believe in the devil is, and then whatever you get. Again, really simple sentence. So I'm gonna write sentence. All right, our last part, and we're pretty much almost done. We have just a little bit of notes left and then an example. It says using the mean and standard deviation. So if you remember, the mean was n times p, or n, sorry, it was n times, yeah, p of x. It's actually the same formula. So let's go ahead and write this. This is only for binomial distribution. Okay, so some things that you need to know is for your mean, we're using the same formula, it's mu, but this time you don't add up all of the values, it's just n times p. How many trials you got times the probability, that should be your average. Thinking about it, if I flip a coin 10 times and the probability of getting a heads is a half, well, what's my average? Well, I'm supposed to get 5 coins, okay, because 10 times a half is 5. Okay, that's your mean. What's the next thing you would need to do is you need to find your variance, which is sigma squared. And the formula for that one is n times p, which is exactly the same thing as mean, but times q, times the number of failures. And how do I find my standard deviation? That's sigma. I take the square root of n times p times q. Okay, same thing like as before. Some rules of thumb, and I tell regardless to recall it. So significantly low is when you have mu minus 2 times sigma or lower, and high is 2 plus 2 sigma or above. Notice I kind of go through this quickly because we already did this like 3 times. Values that are not significant are when they are between mu minus 2 sigma and mu plus 2 sigma. All right, so let's go ahead and do our last example. Okay, so example involving n equals 460 overtime wins in the NFL games. We get probability of 0.5 being p and q equaling 0.5. I'm just gonna write q equals 0.5 here. By assuming that winning overtime coin tosses does not provide an advantage, so both teams have the same 0.5 chance of winning games in overtime. Again, that's true, but we're gonna assume that just for the sake of this problem. Okay, so the first part says find the mean and the standard deviation of the number of wins in the group of 460 games. Okay, so the mean, and I don't have to write the word mean, I can just write the variable. So mu equals n times p, and it's just the formula from the first page. So n times p, well, your n is 460 because that's how many games we're looking at. And what's my probability of success? Well, I wrote it right here, 0.5. And what is 460 times 0.5, or half of 460 is 230. And we're done. Let's go ahead and find the standard deviation. Notice I don't ask you the variance, I ask you just standard deviation. So standard deviation formula is the square root of n times p times q, which is the square root of 460 times 0.5, I was going back to the last one, times 0.5. And how many decimal places should I round to? 3. So I get 10.724, and I just used my calculator, and that's what I got. Again, try out, see if you're getting the same answers. Okay, so it says use a rule of thumb to find the value separating the numbers of wins that are significantly low or significantly high. So I'm actually going to do it down here just because there's all this space and I don't have to do this. So let's go ahead and do low first, and then I'm going to do high. So low, the formula is mu minus 2 sigma, and high is mu plus 2 sigma. All right, so our mean is 230 minus 2 times 10.724. You're going to calculate that. Okay, our high is 230 plus 2 times 10.724. And we're going to calculate that. So I'm just going to use my calculator. I'm going to do 230 plus 2 times 10.724. All right, 251. Oh, that's plus. So 251.448. And then again, I'm going to use my little trick. I can highlight this, and then we can just change this to a minus sign. And I get 208.552. Okay, and that's part B. It says use the rule of thumb to find the winds that are significantly low and significantly high. That's it. So part C is 252 overtime wins in 460 games significantly high. Well, okay, well, here's high, so we're looking at just this part. Okay, the high is this or above. Is 252 this or above? Yes, it is. Okay, so this is above. So if it's above, is it significantly high? Yes, it is. Yes, because 252 is above 251.448. So it is significantly high. Okay, that is the end of the chapter 5 notes. Thank you.